Okay, students, now we will discuss the next topic, that is the heating effect of current. You know, whenever we take any charge from one point to another, then we have to do the work, and that work is given by potential difference multiplied by the amount of charge. The same way, when the current is flowing through a circuit, then charge is flowing from one point to another. It means now the source has to do the work in taking the charge from one point to another, and this work appears in the form of heat. This you can simply compare when we rub our hands, then we do the work against friction, and that appears in the form of heat, that our palms becomes warm. Similarly, whenever we are doing work, that appears in the form of energy. So in this case, you know whatever amount of energy will be there, up say for example, in this case the total work done will be potential difference into charge, and by Ohm's law we know V is I into R, and amount of charge is given by I into T, where I is current flowing through the wire, T is time taken, V is potential difference, I is current, and R is resistance. So we get the value of work done as, if we substitute the values of I, then we get V into I into T. This is the first formula of work done. Then if we substitute the value of V by using Ohm's law, that V is I into R, then we get the second formula, I square into R into T. So that way we say whatever work we are doing, it will appear in the form of heat. So heat developed is given by I square into R into T. It means heat developed in a wire when the current is flowing is directly proportional to square of current, directly proportional to its resistance, and directly proportional to the time for which the current is flowing. And this is called the Joule's law of heating. Now if you see the another formula, the H is first formula I square into R into T, second formula is V into I into T, and third formula, if we substitute the value of I instead of V using the Ohm's law, then the third formula is V square upon R into T. That way we can say we are having in all three formulae. Now if we have to calculate the total amount of heat generated in a circuit, we can apply either of the three formula depending upon which quantities are given in the question. But if we have to compare, like for example 2 or 3 bulbs are given and they are asking which bulb will glow brighter or something like that, and we have to compare, then in that case if the series combination is there, you know the current remains constant, so we apply the first formula I square into R into T. Similarly, if we have to compare for the parallel combination, then we apply the formula V square upon R into T. And SI unit of heat is joule. Now we know practical application if we see, then in the daily life we are using the electric iron, electric geyser, and then electric bulb. In all we are using the heating effect of current for the constructive purpose. And one more instrument where we use it is electric fuse. Now in the normal bulbs and then you can say the electric iron or geysers, so we are using the wire which is, that is, or you can say the filament, and that is called heating element. And this heating element, the material of that is, normally we use alloys, so normally that is tungsten, because its melting point is very high, so it will not melt easily at high temperatures. And secondly, its resistivity is high, and you know resistivity decides the material, whereas the resistance is variable. So in this case, if the resistivity is higher, so automatically the value of R will be higher. So we select those materials for which resistivity is higher, so that by the formula of I square into R into T, the heat developed will be more. Now the same thing is happening in electric iron or geysers and all. And one more that device that is important from the point of view of 3 marks, that is your electric fuse. It is a safety device which we use in our domestic circuit. So basically it is made up of lead tin alloy, ya copper tin alloy, ya pure tin. And the characteristic of its materials are low melting point, because it should melt whenever the current exceeds the permitted value, and high resistivity. So whenever the current in a circuit increases because of any reason, like short circuiting or overloading or something like that, then the amount of current in the circuit will increase. So accordingly heating will increase. So the fuse wire will melt and switch off the circuit. So all the appliances will be saved. Nowadays in our domestic circuit, instead of fuse wire, we are having MCBs. So in the fuse wire we have to replace the wire, and if that thing is say suddenly happening at night, then we will not get that wire of that particular rating at night. So nowadays when we are using MCB, so it is much more convenient to use, because only we have to switch it on again. And the maximum current that can flow through a fuse is called its rating, and normally it is always there in the whole numbers, like 1 ampere, 2 ampere, 3 ampere, and so on. These are normal household circuit. We use fuse wire of two ratings. Number one is 5 ampere. 5 ampere is simply for lightning circuit, like for example the small instruments which don't use or need, you can say, the high amount of current, like your electric bulb is there, or the CFL is there, or the tube light is there, something like that. And second line is 15 ampere, and that we use for heavy power appliances, or that is called power line. And like for example you are having geyser, your mixer, washing machine, TV, AC, so we use for that this high 15 ampere line. Now electrical power, the next power that you have done in class 9th, rate of doing work is called power. So in this case power is work upon time. So that way if we substitute the values of work, means the three formulae which we have done. So again we will have three formulae for the power, that is V into I square into R, and V square upon R. And SI unit of power is watt. So now the next thing is commercial unit of electrical energy. So if we see the formula of power, then we can say work is power into time. The SI unit of power is watt, time is second. That means if we use any appliance of 1 watt for 1 second, then energy consumed will be 1 joule. So that way you can say if we are paying the bill for the month, so that way the 1 joule is very small amount of energy. So in the daily life we use the bigger unit, that is 1 kilowatt appliance we use for 1 hour, then whatever energy is consumed, that is called 1 kilowatt hour. And if we have to calculate the value in SI unit, then 1 kilowatt hour means 1 kilowatt into 1 hour, converted into watt and seconds, the 1000 into 60 into 60, that way we get 1 kilowatt hour is 3.6 into 10 power 6 joule. And this 1 kilowatt hour is also called the unit. So in the daily life we pay the electricity bill for the units consumed by us in a month. Now in the next video we will take the numericals or the questions based on heating effect.